Okay, let's go ahead and get started. Thank you all for your patience. The keynote ran long, and that meant it was that much longer for them to set up the New Zealand rooms 1, 2, 3, and 4 across the street. I happened to be in 4, so the previous session started about 20 minutes late. We were able to make up some time, but I know we're a little bit late on this session, so I appreciate your patience on that. Let's go ahead and get started. This clicker will work. There we go. Hello. All right. So for those of you who don't know me, my name is Scott Schnall. I'm a Senior Program Manager on the Office 365 Customer Experience Market Expansion team. It's a very long name for a team that basically is, as the name implies, we're here to help remove any barriers that you have around adopting or using Office 365. So I've got my email address up there. If you have questions, whether it's related to this particular session or not, questions around Office 365, please do feel free to email me and I'll do my best to get you some answers. So today we're here to talk about encryption in Office 365. We're going to talk about both the encryption technologies that we have in the service, both service side and customer managed technologies. And then we'll talk about some of the common customer concerns around threats and scenarios for threats and the encryption technologies that we have to mitigate those threats within the service as well. So let's start with a discussion about content at rest. So for customer content at rest, within Office 365, there's two things that we're currently doing. First, all servers, Exchange Online, Skype for Business, SharePoint Online, and so forth, all of those use BitLocker for all of the disks that are hosted by that operating system. BitLocker for all workloads except Exchange is deployed with AES 256. Exchange started very early in Office 365, and when we initially rolled out, we were using AES 128-bit, but we've since phased that out, and we're moving to 256-bit for all the servers. But there are still some 128-bit BitLockered servers in Exchange Online, but by and large, everything else is 256-bit. So BitLocker is provided by Windows. There is also a secondary encryption mechanism that we're using, and internally we call it Advanced Encryption, and in fact, that's the brand name we're using for Exchange Online. SharePoint Online calls theirs per file or file level encryption, and that's for SharePoint, OneDrive, and Skype for Business. Advanced encryption for Exchange itself, for Exchange Online, is currently in preview, and it's expected to be generally available by the end of this calendar year. So before December 31st, everyone will be able to use advanced encryption. And there's also a bring your own key option that I'll talk about in a little bit. SharePoint Online already has deployed advanced encryption. Their BYOK, bring your own key feature, will start first quarter of next year. So Exchange is going first, then SharePoint will follow suit. And as I mentioned, BitLocker we've deployed with AES 256 on all new servers, but Exchange Online, since it's been around for a while, still has some servers that are only at 128-bit. Those are all being phased out, and new servers are replacing them that are 256-bit. Now, for the encryption, Office 365 stores the master key that it uses, and these are the keys that are used to wrap the keys that are used for encryption. So these master keys are stored in a secured share, and only the appropriate individuals within Microsoft have access to those. And the credentials for those keys are stored in a separate secret store, and that requires an even higher level of elevation and access in order to get to them. And that's something that it would literally be like a CVP or a general manager level or higher before somebody would get authorization to do that. All elevated access, if there's any type of DR work that we need to do or anything like that, all of the elevated access is logged and audited and controlled by the same mechanism. So when we say your data is encrypted, even though we hold these keys, we keep them very secure, and we audit their use and their access, and we take management of it very, very seriously. In terms of the BitLocker keys, BitLocker uses two types of keys. One is a BitLocker managed key, and that's created when the operating system is instantiated and BitLocker is enabled for the first time. That key generally has a very short life cycle in Exchange and some of the other workloads because the servers themselves don't live for very long. As you might know, for example, in Exchange Online, we don't patch our servers. We flatten them. In other words, we turn them into bare metal about every 2 weeks, and then we redeploy them with the latest bits. So there really is no patching of the individual servers. We patch the build, and then new builds go out every couple weeks. Now, there's also recovery keys in BitLocker, but those are actually managed outside of BitLocker. And again, some of the workloads will use them. So again, with an example from Exchange Online, there's a managed availability feature where it's doing monitoring of the disk volumes. One of the things it monitors for is to make sure that the volume is encrypted, but also unlocked and available for operating system use. And so there are cases where, as part of a recovery action, managed availability responders may need to unlock a disk, and so they'll need access to the recovery keys to do that. So it's only Exchange Online that will actually use the recovery keys and a data recovery agent. The other workloads, SharePoint, Skype for Business, OneDrive, and so forth, they will only use the BitLocker managed keys. Now, BitLocker is volume level. Okay, so when you enable BitLocker and you encrypt the volume, it's encrypting the whole in volume with a volume master key. And there is, in the United States, there's the United States Department of Commerce. That's a regulatory agency. Within the U.S. Department of Commerce, they have a non-regulatory body called the National Institute of Standards and Technology. It's this organization that sets the Federal Information Processing Standards, or FIPS, and these are the standards that have the crypto algorithms that BitLocker uses. So BitLocker is FIPS compliant. So if you do keep up with standards and whatnot, BitLocker is FIPS compliant. It's FIPS 140 level 2. And so what that means is the servers themselves have been FIPS validated as well. And that's important to remember. So the operating system in BitLocker is compliant, which means it's got the certifications from NIST. NIST itself has tested them and verified our crypto algorithms and the key management and everything else. The servers, though, when they run with these encryption modules, they become FIPS validated because the workload itself has not been certified by FIPS. So if you see what looks like conflicting statements where some things are FIPS compliant and some things are FIPS validated, it's really down to the certificates that they have against them. Okay, so file level encryption or per file encryption, or what we sometimes call advanced encryption and what we're now calling advanced encryption for Exchange, that's used by Skype for Business, SharePoint Online, and OneDrive for Business because those are largely the only ones that work with files. Exchange, we work at the mailbox level for encryption. We'll talk about that in a minute. So data at rest, it might be stored in the form of files, or this could be presentations that are uploaded by a meeting participant. And all of those are stored on the web conferencing server using, at a minimum, AES with a 128-bit key. There is other data that is also encrypted that could be stored on a file share, and if that happens, that data each piece is stored with a randomly generated 128-bit key. And then the encryption key itself is stored in an XML metadata file, which then also gets encrypted with a per conference key. So every conference or every meeting that you create in Skype will end up generating its own unique key for any content that is uploaded into that meeting. For SharePoint and OneDrive, this is always a unique per file key, and by unique, it's unique within a single tenant. So none of the other tenants have access to your key or can see your key. And when you upload a file into SharePoint, it actually disassembles the file somewhat. It carves it into chunks, if you will, and each of the chunks is encrypted with a separate encryption key, and the chunks and the keys are stored in separate stores. And the chunks are usually encrypted with different keys as well. So what that means is even if you could have access to one key and somehow manage to decrypt it, you don't have the other chunks that make up that file, so you wouldn't really be able to make that data intelligible or do any kind of reasoning over it by virtue of cracking one file open. And then, as I mentioned, every step of this encryption process is the FIPS 142 level 2 validated. Again, not certified because there's no certificate, but because we're using the FIPS modules, it's FIPS validated there. So I mentioned the number of chunks that we break a file into really depends on the file size. Generally, though, at a minimum, the smallest file that you can upload is generally going to be cut into at least 3 chunks. And like I said, each of those chunks is going to be encrypted using its own key. And then the chunks themselves are stored as blob storage or blob data, free-form data inside of Azure Storage. And that gets randomly distributed across multiple Azure Storage accounts. So there is a lot of abstraction of the data going on. And every layer in which we have abstraction, we're also doing encryption of that data as well. So that could be on the SharePoint side, that could be on the metadata side, that could be on the Azure side, and so forth. Now, the set of encryption keys that we use, they also end up getting encrypted, and they're encrypted with another key that is generated independently of the master key. So we have the key that's used to wrap each chunk, then we have the key that's used to encrypt that, and then that key is stored somewhere else, and wherever it's stored, that's encrypted with a separate key as well. And as you might imagine, this chain of encryption makes it, with each level, exceedingly that much more difficult, if not impossible, to be able to decrypt this data in an unauthorized fashion. Part of it is because some of the data is held in the SharePoint content store, and that's encrypted with one key, but the master keys themselves are held in the key store, and that entire key store is not only encrypted with one key, but the individual keys within the key store are encrypted with separate independent keys as well. When the files are broken into these chunks, there's a map that's created. The map is basically the instructions on how to put the chunks back together and then decrypt them. So the map itself is stored inside the content database, the same place where we store the encryption keys, but it's stored separately from the master key that's needed to decrypt it. So a breach or a leak of the data inside this content database would not expose the actual key that is needed to do the decryption. So the map is inside the content database, and you'd have to query the content database with the proper security credentials or as the service itself, in other words, SharePoint Online Code, in order to get the keys that would be needed to decrypt the data that was held in there. Now, each Azure Storage account, and remember there's multiple Azure Storage accounts that come into play when SharePoint is encrypting. Each storage account has its own unique credentials for reading, writing, enumerating, deleting, and so forth. So here again is an example where if one thing got breached or exposed somehow, it's not going to expose everything else. In part because the key store is physically separate from the content database and separate from the Azure storage where the chunks of the files actually live. And there's a key ruling mechanism that happens as well. So both the credentials and the keys themselves that are stored in the content database, those are rolled periodically and refreshed periodically. I want to say every 60 days they're rolled. So all of these 3 repositories where we store the encrypted data, all of them are completely separate, and the way in which we carve up the data and encrypt it basically makes each piece completely unusable without the other pieces. So without, as you can see, without access to all 3, it would be impossible to receive the key from the chunks. It'd be impossible to decrypt the keys to make them usable. And then even if you could do that, it'd be almost impossible to be able to associate them with the corresponding chunks because there's nothing that a human could determine that would tell it what chunk goes with what encryption key. So it would be impossible. The only way to reconstruct these files and decrypt them exists inside the SharePoint Online code. So it would really be only SharePoint Online that could decrypt and reason over this data. This one is actually redundant with the prior slide. So yes, so the keys are updated, as I mentioned, every 60 days. So even if you could crack one key a couple months later or less, it's going to be completely invalid and not used anymore. So the credentials that we use not only include the encryption keys, but it also includes the disk signatures from the actual storage itself. And as you might know, the signatures are going to be unique to each disk. Those also get refreshed every 60 days as well. They auto-expire, we generate a new one and start rolling with that. And as I mentioned, the different credentials that we have for reading and writing are held completely separate from one another, and it's not a permission that we actually give to SharePoint to do that enumeration. That's all happened within Azure Storage. Now, list items are a little bit different. So up till now, we've been talking about files in SharePoint, but you also have these list items. List items themselves, they're smaller chunks of content. That could be something that could be created ad hoc by a user, or something that could be generated dynamically within a site, depending on how you've set up the site. The list item contents are not protected with the advanced encryption. They only get protected with the BitLocker encryption. So they still are protected with BitLocker, but as you'll hear in a couple minutes, there are some limitations of BitLocker that advanced encryption allows us to overcome. But we can only use advanced encryption for discrete objects. We can't use them with a dynamic list that could be created by service code. But for files, we don't have a problem with that. So if you were in the last session, you heard me talk a little bit about the assume breach philosophy that we take. And that's basically a mindset that says, from a security perspective and from a security posture, we just make the assumption that the bad guys are going to get in, okay? That controls are going to fail, or vulnerabilities are going to be found, or maybe an internal Microsoft folks becomes the victim of spear phishing, or they just become rogue or malicious and they want to do some bad things. Because we have assumed breach, we basically take the approach that nothing and no one is to be trusted, not even our own administrators. Even though we do rigorous screening and whatnot, we still take the approach that the bad guys are eventually going to be on the inside, and we want to have protection mechanisms that prevent them from doing bad things. That's one of the reasons we have BitLocker. Okay, so if somebody does break into a data center somehow, even though it'd be almost impossible to do that, but if a control fails and drives containing Office 365 data are not destroyed properly, in fact, we have a policy where we destroy them on site. We've actually got a machine that you feed them into, and it literally chops them into teeny little pieces with a window where you could watch it happen to verify this. But let's say somehow that control were to fail. One of the challenges with BitLocker is BitLocker, because it's integrated with the Windows operating system, means that the administrator account for that OS has access. There's an assumption in BitLocker that the administrator of the BitLocker protected volume is either allowed to access the data or at least an authorized user of the data at some point. And as a result of that inherent assumption in BitLocker, we had to come up with separate encryption to basically break the ability of our internal administrators to be able to get to encrypted content. The other thing with BitLocker is it precludes any bring your own key scenarios, because the keys are wholly generated by the operating system, and there's no way for us to take a tenant key and use that for BitLocker. So there's a couple of problems that we have. So that's where advanced encryption comes into play. Advanced encryption, in the case of SharePoint, like we just talked about, and OneDrive and Skype, they're using it in the form of this per file encryption. So every file in those workloads is encrypted using what we call advanced encryption. In Exchange, we're calling it Exchange Online Advanced Encryption, and that will be encryption at the mailbox layer. Okay, so that could be a key that is generated by Azure Key Vault, or we also will be supporting the bring your own key story with Exchange Online. That is expected to be generally available by the end of this calendar year, and SharePoint Online are doing their BYOK the first quarter of next calendar year. So Exchange Online benefits from advanced encryption. Everybody's getting their mailbox encrypted, whether you bring your own key or not. It's just a question of which key is used as the root key. And even though it's Exchange Online, a lot of Skype for Business data is held in an Exchange mailbox. So any Skype data that's held in a mailbox that's encrypted with advanced encryption, the Skype data will also be encrypted because everything in the mailbox is. So advanced encryption has several benefits and advantages over BitLocker, one of which it allows us as a multi-tenant service provider to allow per-tenant key management. So you can, like I said, generate a key yourself using Azure Key Vault, or if you have an on-premises hardware security module or HSM, you can generate your own key in that, and that key can be uploaded into Azure Key Vault and stored in one of our HSMs in our data centers, and then that key is used by the other services. And it does because it has nothing to do with the Windows operating system. It doesn't have the vulnerability that BitLocker does, where the administrator of that system has full control and the ability to unlock the drives. But the real reason that we introduced this, particularly the BYOK feature, is to allow customers to render all of the data that they may have stored with us completely inaccessible if they decide to terminate and leave Office 365. There are some customers around the world that have regulatory requirements that require, when they leave the service, not just that the data is deleted, which we'll do after a certain amount of time, but they also have the requirement that as soon as the contract with the service provider is terminated, all of the data that the service provider was processing on their behalf has to be rendered inaccessible to the service provider. And so this is really where advanced encryption with BYOK came from. The need for some customers to be able to control the key that's used to encrypt their content and to render that content inaccessible by virtue of revoking access to that key when they terminate the service. So let me walk you through the scenario of how it works. It's super easy, as you can see from this. It's really just a few steps. There's hardly any moving parts. This actually does not even tell you everything that we want to do. So believe me, I've actually made this as basic and as simple as I could, but there's actually a lot more that's involved with it. So let's start at the beginning. You decide whether or not you want to use BYOK. If you're not using BYOK, then advanced encryption, for instance, for Exchange Online, just happens automatically, except that we manage the key that is used as the root key. If you want BYOK, the way it works, like I said, you do one of two things. You either generate a new key in Azure Key Vault, and then you'll manage the vault, and that key will be associated with data encryption policies in Exchange, where Exchange will have wrap and unwrap privileges for that key. That's the extent of what it'll do. Or the other option is to, like I said, if you have an on-premises HSM, which is that hardware device with the keys on it that you're seeing, we only support the Thales device, and that's what we use in our data centers. If you have one of those on premises, you can generate your own keys from that, and then you upload them into Azure Key Vault. Now, when you're doing this, what we really want you to do is we want you to upload at least 2 keys for every data encryption policy that you're creating. And we would strongly recommend that each of those keys be managed by separate administrators in your organization. And then on top of that, we would strongly recommend that the keys be in separate geos, if possible, to give you geo redundancy and so forth. Now, the reason for 2 keys is simply as a protection mechanism, and the reason for separate administrators is the same. Having 2 separate administrators and 2 separate keys means that one administrator cannot go rogue and revoke access to a key or trash a key, thereby rendering all of your data inaccessible. If the key that's used to encrypt it, if the services no longer have access to it, or you've revoked it from us, then there's no way we'll be able to read that data or recover that data. And so we want to protect you from that happening, and that's why we strongly, strongly recommend that you have 2 keys for each policy and that they're managed by separate administrators. The other thing that we also want is no expiration for the keys. So you can certainly generate new keys and do key rolling operations if you want, but the keys that you give to us, we don't want them to have expiration dates because, again, if that key expires, no one and nothing is going to be able to unlock or decrypt that content. And we don't want you to do something or have a malicious administrator do something to you that would lock you out of your own data. So there's a lot of protection mechanisms we have built into the requirements around this. So you've got the key, whether you generated it yourself or not. It's up in Azure Key Vault. Then in Azure Key Vault, that gets created and associated with your Office 365 account. And then you give permissions to Exchange and to SharePoint and to Skype to, like I said, do the wrap and the unwrap operations. And the key that you provide or the key that you generate through Azure Key Vault, that will be the root key that's used in the encryption chain. So there will be a key that the workloads themselves will use that will actually be the key that's encrypting the data. And then that key and the data will be wrapped with your key. Okay, so your key is the root key that you would hold and have control over. All right. So here's another way to look at it. There's actually just a few steps that you end up having to do, and there's a couple commandlets that you have to run. Some of them are new, like the new data encryption policy. That's a brand new commandlet. In fact, it's so new, it's only available right now to preview customers, and I don't think you'll find any documentation out on TechNet for it yet. But by the end of this year, once this feature is GA, when we ship the feature, we'll ship the content with it, and you'll have full steps on how to do it. But again, it's a very simple process. It's all about getting the keys into Azure Key Vault, granting the services in Office 365 permission to do wrap and unwrap operations with those keys. And then within Exchange, you'll create a data encryption policy and assign that to mailboxes. And we'll let you create as many as 50 data encryption policies. So you can have different policies if you've got different geos or different departments where you want different keys being used to wrap their mailbox data. You can do that. Or if you want to have everybody be in the same data encryption policy, you can do that as well. It's really up to you as to how you want to do your encryption scheme. But again, the only thing I would say is we're going to want you to have at least 2 keys with every data encryption policy with separate administrators so no one can go rogue and really ruin your day. All right, let's talk about data in transit now. So we've talked about data at rest. For data in transit, all customer servers negotiate a secure session using TLS, and you can actually test this yourself. There's a company out there called Qualys, and you can go to their website, punch in the URLs for Office 365, and it will tell you the crypto scheme that's in use, and it will also give a grade as to the strength of our cryptography as well. And you'll see if you do that, all of our services and workloads have a grade of A from this third-party company, and all of them are using very strong encryption. And all the details on the crypto suites that we use and the ciphers that we use, all of those are documented both in TechNet and in a white paper called Data Encryption Technologies in Office 365 as well. So everything that we do with respect to the crypto architecture across Office 365 is fully documented as part of our efforts to be transparent with all of our customers. Exchange Online uses TLS to encrypt connections between all the other Exchange servers in Office 365 and between other servers such as the recipient server when you send an email to someone. We use a 2048-bit SHA-256 RSA certificate. And actually, if you walk that up the chain and look at the root certificate is 4096-bit, so it's even stronger. And because it's TLS 1.2 with 256-bit cipher strength, it's also FIPS 140 to level 2 validated as well. Now, along with the encryption technologies that are built into Office 365, there are also a whole set of technologies that are customer-facing and customer-managed as well. So things like Azure Rights Management Services, which is now part of Azure Information Protection, S-MIME, Office 365 Message Encryption, which is based on Azure RMS, and the secure mail flow that we allow you to set up with partners and other Office 365 tenants. So Azure Rights Management. This is using a combination of encryption, identity, and authorization policies to allow you to secure individual files on a one-by-one basis. And this allows these files to be encrypted and decrypted on basically any device, any tablet, any operating system that we support, any mobile device that we support, and so forth. And one of the benefits of Azure RMS is the protection remains with the data. So that could be protecting data that is within your organization, or you may be sending files or documents outside your organization, and the protection remains with them. And in fact, if somebody tries to forward something that's RMS protected to somebody who doesn't have rights to do it, all they're going to see is an encrypted document that is meaningless to them. It's not just for Windows, although it works great on Windows, but will work on any platform that we support client access for Office 365. So this could be iOS, this could be Android, and of course this could be Windows, this could be a web client, it could be a mobile client, and so forth. There is also auditing that goes with RMS as well. So you can see, for instance, when a file was encrypted, by who, and also when a file was decrypted and read, and by who and on what device as well. So there's a lot of reporting that's available within RMS as well. We do offer RMS for both cloud and on-premises servers. So if any of you have a hybrid configuration, we can use the same single Azure RMS instance that's associated with your tenant, can also be used to encrypt your on-premises information, and also if you're in a hybrid, exchange encrypted information between on-premises and cloud users as well. And Azure itself is using a 2048-bit RSA symmetric key with SHA-256 for encryption. And if you encrypt an Office document, that's AES 128-bit, and it's CBC-BO with PKCS #7 padding if you want to really geek out on the details. Like I said, we have a lot of documentation on our Cypher suites. In the default Azure RMS implementation, it's actually us who generates and manages the root key that is unique for each tenant. Like I said, though, you do have this option for Azure RMS of doing bring your own key. You would need an on-premises HSM to do that, just like you would with advanced encryption. And once you transfer the key to us, the transfer would take place in an encrypted channel, and the transfer would deposit the key directly into hardware security module, where it would also be encrypted to FIPS 140 level 2. And then access to the root key would be given out to the individual applications, not to any humans, but to the code itself. So Exchange Online, SharePoint Online, and so forth. And this is one of the areas where it is very near real time in terms of auditing and logging of access, both encrypting access and decrypting access as well. Some things can take a while to make their way into the audit logs, but things around Azure RMS and usage, that is very near real time, and that should happen in the logs very quickly. All right, SMIME. Anybody using SMIME? Yeah, it's usually the reaction I get. SMIME we put into the product and we continue to support largely because the United States Department of Defense and a lot of their organizations like the U.S. Army and the U.S. Navy and some of our military units, they are big proponents and users of SMIME. And if you haven't used it, it basically allows the end user to both digitally sign and or digitally encrypt individual mail messages. Like I said, it's not something that's widely used either outside the U.S. or really outside the U.S. DoD. There are some customers that use it simply because we have it, but by and large, the driving reason it's in there is because of our military services in America. So we do support SMIME in Office 365, and it is integrated not just on the service side, but also, for example, in the Outlook client. So if you did want to do distribute your own certificates, if you've got your own internal PKI, and you want to distribute your own certificates to your users, you could certainly dole out SMIME And that would be usable through Outlook, Outlook on the web, which is the new name for Outlook Web App, or OA as we used to call it. It's now called Outlook on the web. And the Exchange ActiveSync clients also honor it as well. And that's important to know because you don't need to go out and get, for example, Outlook for your mobile devices. The native ActiveSync client will use it. There are some other good reasons for getting the Outlook client, but if you don't have that, the ActiveSync client handles it just fine. Now, Office 365 message encryption, this is another way that end users can encrypt individual messages going to other users, and then the user can decrypt them either using a Microsoft account if they have one, or if they're also an Office 365 tenant using that credential, or if they don't have a Microsoft account or don't want to create one, they can request a one-time passcode which will be sent to them, and then they'll be able to use that passcode to unlock and decrypt the email. But OME is basically the more modern way for end users to send encrypted mail outside of the organization and still allow someone to decrypt it. All right, so I mentioned the secure connectivity with partners. How many of you have actually deployed Office 365 in production today? All right, and how many of you have created secure connectors, especially connectors? Okay, a few hands, okay. So if you haven't, we give you the ability to create specific connectors for partners or a special organization, maybe another Office 365 tenant, and this will basically force the use of TLS over this connection. You won't be able to transmit messages to the receiving server unless the receiving server is also using the same level of TLS. If they're not, the messages won't be delivered. So you'll be guaranteed for messages that are delivered that they were in fact encrypted, in this case with TLS 1.2. This feature alone, in the encrypted and secured connectors, this right here defeats any man-in-the-middle attack. Anybody who may be intercepting that traffic, whether it's someone who's gone rogue in our data center or someone who's got some form of tap on the internet and they're pulling that data, they're just going to get an unintelligible stream. They won't be able to decipher it or decrypt it whatsoever. So it's a very effective defense against man-in-the-middle. And in fact, let's talk about some of those scenarios and mitigating policies that we have. So one of them I've already talked about. What happens if we have a control within the data center fails so that the disks are stolen or improperly recycled? So stolen is something that we have to plan for, but the chances of that actually happening are very, very slim, very, very slim. But there is a potential chance that a disk could be improperly recycled. Maybe somebody didn't throw it in the machine right away, and that is why BitLocker and advanced encryption or per file encryption are there, so that if a disk does make its way into the wrong hands, none of the data on that disk is going to be readable without the decryption keys, which whoever now has that disk is not going to have access to. So if you're worried about disks getting stolen or improperly recycled, the fact that the data on them is encrypted, in some cases with two completely separate forms of encryption, should give you peace of mind that that scenario is not really one that you need to worry about. If a hacker tries to access an individual file or data through some sort of API that exposes it as blob data, again, the per file encryption will simply render that unintelligible for them. There's nothing that they could do at that point to decipher or decrypt that data. If there were some way for unauthorized access to go across a tenant boundary, again, per file encryption or advanced encryption is the defense against that scenario as well. For those of you who were not in the tenant isolation session I did previous to this, I'd recommend going and getting the slides and the recording, because there is a lot of stuff that we've done both in Azure Active Directory and in Office 365 to provide logical isolation of tenant data. And in fact, it's extremely difficult, if not impossible. I can't technically say impossible, but it's extremely difficult for someone to, within one tenant, to breach that boundary and get to data in another tenant without having that second tenant provide them explicit authorization. But if they could do that, if there is some unknown vulnerability that we haven't discovered yet that does allow you to go over the tenant wall and query another tenant's data, you're not going to get anything because, again, that tenant's data is going to be encrypted with a per-file encryption. And again, remember, whether you choose BYOK or not, we're encrypting everything. The BYOK is just an extra thing you can do on top of that. The man-in-the-middle attack, or someone tapping the data flow on the internet, again, TLS in between Office 365 and all the clients. I mentioned that we're using that everywhere, and you can go to the Qualys website and actually see the report of our usage of TLS. Or if there's a man-in-the-middle attack that happens within a data center somehow, or within an ISP, one of the peers that we use that feeds one of our data centers. Again, TLS between Office 365 data centers is also used to mitigate that as well. Again, it's going to be an unintelligible encrypted stream of content. And then the last couple of scenarios that we have, data falling into the hands of someone it shouldn't. Now, yes, we have a lot of features around data loss prevention that you can enable and create all sorts of policies to prevent that sort of data leakage. But on top of that, if you use encryption technologies like rights management services, for example, if there is a data leakage, it's not really going to leak the data itself. A file might get inadvertently sent to the wrong person or make its way outside your organization. But if it's RMS protected, the person who receives that file, who's not authorized to use it, won't be able to open it or really do anything with it. They'll just have an unintelligible blob of data that they can't access or do any kind of reasoning over. And that's the same thing with general email. I mean, we can stop files from going in their hands, but we also have DLP that prevents you from leakage through Exchange Online as well. But if you want to add additional layers of protection on top of that, you could do that with SMIME, you could do that with Office 365 message encryption, and you can do that with RMS. They're all just different forms of encrypting the content. And in fact, OME, Office 365 message encryption, and rights management services are based on the same crypto modules. It's actually Azure RMS runs those crypto modules. So it's based on the same thing, and they largely have the same strength of encryption. So it's really just a question of which one you prefer to use if you're choosing between the two. And then the man-in-the-middle attack between you and a partner organization or someone that you've set up an explicit connector with, that is protected through secured connectors where you basically force the use of TLS on that connector and not transmit anything if the receiving side does not honor that. All right, so in terms of the summary, we've talked about numerous service-side technologies that we have for encryption. So that includes not just BitLocker, but advanced encryption. Again, the naming can be a little confusing because we are still using the name advanced encryption with Exchange Online, but with SharePoint, Skype, and OneDrive, we simply call it per-file encryption. It's the same exact thing. So for customer content at rest, it's going to be the per-file encryption or BitLocker, and soon the mailbox level encryption once Exchange becomes GA before the end of this year. And then for content in transit, whether it's between a client or a partner organization, all that can be secured with TLS 1.2. And there is all of this plus a whole lot more available for reading in the data encryption white paper that's available on the Service Trust portal or in the Security and Compliance Center, which is the protection.office.com. I would recommend, if you already have an Office 365 account, going to Service Assurance is easier because there's no onboarding process. STP, or the Service Trust portal, does require a separate onboarding process. It actually does require that the global administrator for your tenant account authorize the application, and then they would also have to grant permissions through the application to other users. So it can be kind of a pain to have to go through all that. All of the information that we published in the Service Trust portal, not just these white papers, but there's also literally our audit reports. So the standards against which we are audited by third-party auditors, when like SOC, ISO, and some of the others, when they do those audit reports, we are publishing them through STP and through the Service Assurance portal. STP only has those documents. Service assurance has the documents plus a whole lot of other things as well, so that makes it more attractive. If you've never seen either of these, on Thursday in my Exchange Tips and Tricks session, I'm going to be giving you a demo of both STP and Service Assurance, so you can see what both of them are like and how to access both of them, and basically decide for yourself which one you want to use. But either way, this is where you'll find white papers, audit reports, and a whole lot of trust, risk, and governance and compliance information. And then the last thing I'll mention, even though it's not directly related to Office 365, I promised the Exchange team that I would mention that we are accepting nominations for on-premises TAP programs. So if you want to run the next version of Exchange on-premises in pre-release form and help us develop it, you can contact David or visit that blog program and plug yourself into that as well. All right, with that, don't forget to fill out your evals, and I'm happy to take any questions that you might have. Yes, sir.
With the bring your own key, can you have an Azure key and your own key as the two?
That's a great question. So I'll just repeat it for the recording. If I'm doing bring your own key, I'm assuming you're talking with advanced encryption, not Azure RMS. If you're doing the bring your own key, can you have separate keys, one that you generate yourself and one that you generate through Azure KVS? Absolutely, yes, you can do that. That is something where if that's how you want to get your two keys for each policy, that's one great way to do it. The other way would be, of course, to generate both keys in the same place, either on-premise HSM or Azure Key Vault. But if you want to mix and match them, that's great. Ultimately, regardless of where you generate it, the keys are going to be stored in Azure Key Vault. Only Azure Key Vault, only the software code itself has access to the keys. The administrator has to run a couple commandlets to authorize the Office 365 workloads to have access to the keys in Azure Key Vault. And once that's done, software handles everything, so no humans ever have direct access to your keys. All right, anything else? Yes, sir.
Does that encryption require some new licensing?
Great question. Does advanced encryption require new licensing? No, it does not. As I mentioned, we're going to be encrypting, for example, in Exchange. Everyone's mailbox is getting encrypted with advanced encryption, whether you are participating in BYOK or not. What we're doing with BYOK is giving you the option to generate and control management of the root key that is used. But ultimately, there's going to be a DEP key, a data encryption policy key, that will be generated by the workload, Exchange Online, for example. That key will then be used to encrypt the mailboxes that are part of that policy, so you have to assign the policy to mailboxes. And then once the mailboxes are encrypted with that key, then your root key, which comes from Azure Key Vault now, will be used to wrap that encrypted blob. Okay, anything else? All right, well, like I said before, if you think of anything later on, please do feel free to email me. Happy to get you whatever answers I can, and I will be around for the rest of the week too if you want to talk more in person. So thanks very much for coming, and enjoy the rest of the show.